Hello students, after completing indefinite and definite integration in integral calculus, this is the time to discuss about the application of integrals. Application of integrals is one of the very important topic of calculus. From this topic, always a question of 6 marks is there in board exams. So let us begin with the topic application of integrals. You know that to find out the area of certain geometrical figures like rectangle, square, trapezium, circles, you have studied certain formulas, and with the help of these formulas you can easily calculate the area of these geometrical figures. But what about the area of different kind of curves? Like if we need to find out the area under the curve that we obtained in case of sin x, cos x, in case of cubic function, or you can say under the area when parabola is formed. So how to find out the area of these under these curves? So this can be done with the help of integral calculus. So let me start that how to use integrals in finding out these areas. Have a look on this curve. This is the curve for y is equal to sin x. Here, if we need to find out area, let us suppose from 0 to pi. So certainly from 0 to pi, if we need to find out area, then the area that I am going to shade is the area which is bounded between, we can say, x-axis and y is equal to sin x. This is x-axis and this is y is equal to sin x. So if we need to find out the area like between x-axis and y is equal to sin x, then this shaded portion is the required area. So to find out this area, we can use the concept of integral calculus. Similarly, we can find out any of the area, like if we need to find out area from this portion, that is minus 3 pi by 2 to minus pi by 2, again we can easily find out. Now there is one thing more that you should observe, that sum of the area, if you are talking about 0 to pi, this is lying above x-axis. This is one of the very important concept that you should know over here, that whether the area which we need to find out is lying above x-axis, number one. Number two, it is lying below x-axis. As for example, if we are talking about from pi to 2 pi, then this area is lying below x-axis. Okay, so number one, area lying above x-axis. Number two, area lying below x-axis. Here pi to 2 pi and minus pi to 0, or you can say minus pi to minus pi by 2, these areas are lying below x-axis. Now the third thing that we need to observe, that whether the area which we are going to find out is lying towards left hand side of y-axis or to the right hand side of y-axis. So these two areas that we are going to observe from 0 to 2 pi are lying towards right hand side of y-axis, and these areas from 0 to minus 2 pi are lying towards left side of y-axis. So the position of the curve is also matters a lot. And one thing more that depends is whether we are finding out area with x-axis or with y-axis. So let us discuss that how these things affect the calculation of area using integrals. First of all, let us discuss that when area is lying above x-axis. Suppose a curve is given to us. Let me write it as fx. Fx is the given curve, and when we draw the graph or this curve on the rectangular axis, that is on x-axis and y-axis. This is the very first step, that is to identify the curve and to draw its draw this curve on coordinate axis. So let we draw the curve, and this is the curve that I have drawn is for the given curve. Now the question is to find area between x-axis and fx, means the given curve. So from limit will also be given to you कि कहाँ से कहाँ तक calculate करना है. So from x is equal to a to x is equal to b, or you can say to find out the area between x-axis curve x is equal to a and x is equal to b. So if this is the question, I hope you understood the question. We need to find out the area between the curve y is equal to fx, x-axis x is equal to a and x is equal to b. Okay, so we need to draw all the four things over here so that we can visualize the bounded area easily on the paper. So here I have drawn the curve fx. This is the line which shows x is equal to a. So clearly this is a over here, coordinates on x-axis are a0. The second line is x is equal to b. I have drawn over here. So clearly the coordinate will be b. Let me name this area as ABCD, because all the four things that are written over here included over here in this ABCD. This is x is equal to a, one thing, x is equal to b, another thing, x-axis, third thing, and the curve fx is fourth thing. So if we observe it carefully, then we will find out that this area which I am shading over here is the required area which satisfies the given condition. And this area is clearly lying above x-axis. We can write the area of required portion using integral as area of portion, as we named it as ABCD. So I am writing here as area ABCD is equal to integration over the limit a to b. Here x is equal to a, 2x is equal to b. So this a to b, a means x is equal to a, b means x is equal to b. So means we are bounding the area between the two perpendicular lines, x is equal to a and x is equal to b. Here we'll write fx, means the curve under which we need to find out area, and this dx shows that we are calculating this area with x-axis. So all the four things we have written over here: x is equal to a, x is equal to b, the curve, and by which axis we are calculating area. In next portion, I will discuss that if we are calculating this area with y-axis, then we'll write here as dy. So it means dx or dy will be written as according to which axis we are calculating area. So if any of the area which is lying above x-axis and we need to find out the area of this portion with x-axis, then this can be represented by this way, that is integration over a to b fx dx. Now let us discuss when the area lying below x-axis. So in the same way, if the question is given like find the area between the curve fx, x-axis, x is equal to a and x is equal to b. These four demarcations are given to you. These are the two lines, x is equal to a and x is equal to b, that I have shown over here. This is x is equal to a, this is x is equal to b, and the curve fx is this one which I have drawn, this is curve fx. Suppose when we draw the curve is lying below x-axis. Okay, as I have drawn over here. Now we need to calculate area between these four. So this is the curve we have drawn. This is x is equal to a, this is x is equal to b, and this is x-axis. So clearly if we find, then the shaded portion is the required area, and clearly this area is lying below x-axis. Let me name this as PQRS. So we need to find out the area of this portion PQRS, which is lying below x-axis. So as in the previous case, I told you that we'll write it as from the limit a to b. I'll write here area PQRS is given by the limit from a to b with negative sign. So means when the area is lying below x-axis, then integration will be negative. So other things will remain same, that is the limit from a to b, then the curve, and then dx. Why dx? Because again we are calculating area with x-axis. So a change of sign will appear when the area is lying below x-axis. Now the case may be when the half of the area is lying above x-axis and half of the area lying below x-axis. So let me discuss that case also. The next case is when area lying above as well as below x-axis. So here I have taken, this is clearly x is equal to 0, and let us suppose that this is the line x is equal to b. So this is the point b and this is 0. Now and let me name this portion where the curve changes from upper side of x-axis to the lower side. Let me name it as c. So from 0 to c, the area which is which we need to find out, let me shade the area. Here we need to find out this whole area, means the area between the curve fx, x is equal to 0, x is equal to b, and x-axis. So these are the four things with which we need to find out area. So let us, the point C is over here, from where the area is going towards lower side of x-axis. So what we'll do, we'll write it as area is equal to 0 to c. First of all, we'll take the area which is lying above x-axis. So it is 0 to c fx dx with positive sign. As I told you, the area which is lying above x-axis is taken with positive sign. Plus, it is minus, because this time the area is lying below x-axis if we are talking about c to b. So this will be taken with minus sign, and the rest of the area will be c to b fx dx. So in the same way as I have discussed for above x-axis, the curve, the limits, and dx. And if the area is below x-axis, then remaining area will be taken with negative sign, with the limits from which the area start to the below side of x-axis. So it is from c to b with negative sign fx dx. So in this way we can find out area after getting integration of the function and applying the limits for the given curve. Next, we need to find out that how to find out the area when it is lying towards right hand side of y-axis. So here is the curve, and the question will be like to find out the area between the curve x is equal to fy, y is equal to a, y is equal to b, and y-axis. Going to calculate area with y-axis, then we need to choose abscissor over here. That is y is equal to a and y is equal to b and y-axis. And the curve will also be taken in terms of y. So here the curve is drawn. Let us suppose this is y is equal to a. This is y is equal to a. This is y is equal to b. A and b are any constant, maybe negative or positive. So, and this is y-axis. So the area is given by limit from a to b fy dy. As we are calculating area with y-axis, so we will take over here as dy, and the curve will also written in terms of y over here, and the limit is a to b. Here we will discuss to find out the area between the curve x is equal to fy, y is equal to a, y is equal to b and y-axis. So, and if we draw the curve, then we found that this curve is lying towards left hand side of y-axis. So, as in case of x-axis, required area, let me name it as ABCD, is given by area ABCD is given by this is y is equal to a, this is y is equal to b, y-axis is over here with us, and the curve. So this is the bounded area clearly ABCD which I have written. So this is given by limit from a to b fy dy with a negative sign. If the area which we require is lying towards left hand side of y-axis, then a negative sign will appear with area. We should follow certain steps in solving these problems. These are: number 1, identify the given curves or lines whatsoever is given to you in the question, means read the question carefully, and this is the very first step for each and every type of question. Number 2, draw a rough sketch of the given curve. Here the rough sketch means there is no need to take the exact points and exact curve. Just you need to draw the curve in the way that you can identify that which area is going to bound between the given curve and given lines. Third point is identify the area which you need to find. As I have shown you in the above curves, that first of all we'll draw the curve and then we'll mark the area which we need to find out. So identify that area. Number 4, write the required area in the form as I discussed above. Means we need to decide that it is lying on which side of x-axis, y-axis, and according to that we'll write it as integration for on the required limits and fx dx or fy dy with negative sign or with positive sign. Number 5, then after doing this step, simply we need to find our integration as we have done earlier in previous chapter, and then number 6, we need to apply the limits to find out the area. So by doing these 6 simple steps, we can find out problems from this topic. Before going to the problems of this chapter, it is better to recall all the concepts of these 4 figures, which are line, parabola, circle and ellipse. Why these 4 I am preferring? Because in the syllabus of 12th class, we are basically bound with these curves under which we need to find out the area. So let us discuss one by one. You know very well that equation of line is ax plus by is equal to c, and easily you can identify the equation of the line as just we have explained that x is equal to a is given to you. This is also a line which is perpendicular to x-axis. Similarly, another line x is equal to y is equal to a is the line which is parallel to x-axis. Similarly, we can take any line which is in the form of ax plus by is equal to c. So after identify the equation of line, we can draw its graph very easily. Now let me discuss parabola. The simplest form of the parabola that you have studied in your 11th class is y square is equal to 4ax, y square is equal to minus 4ax, x square is equal to 4ay, and x square is equal to minus 4ay. You know very well that this 4a is the lattice rectum of the parabola. Okay, and this is going to be a constant. So we can write, we can be given this as like y square is equal to 3x, or any constant we can use in place of 4a. So here you should know three things about the parabola to draw the parabola very easily. Number one, we need to find out turning point of parabola. To calculate turning point, it will be easy to calculate turning point if we put the term which is in square as 0. So here if we put y is equal to 0, then clearly we'll get x is equal to 0 as well. So therefore the turning point of all these curves is 0, because as soon as we put the term in square as 0, the other term will also be 0. So for all these parabolas, the turning point is origin. Number two, we should know that what the parabola is lying along which axis. So to know, we should take care, we should look at the term, at the variable which is linear, means which is having power 1. So here in this case the x is having power 1. So therefore this parabola will be along x-axis. And along x-axis means, let me draw this to show that what is the meaning of along x-axis. So if I am talking about y square is equal to 3x, its turning point is 0, 0, and it is along x-axis towards positive direction. The third thing that we should know, that in which direction the parabola is. So here, if the signs of square term and the term which is having power 1 are same, then the parabola will lie towards the positive side. So here this parabola y square is equal to 3x or y square is equal to 4ax is having its turning point 0, 0, number one. Number two, it is along x-axis, because we are observing here the variable which is having power 1. So x is having power 1, so therefore it is along x-axis. And number three, towards which direction? So as the sign to both the sides is same, therefore it is towards the positive direction. Now if we are talking about this parabola, this is having turning point as 0, 0. Number two, it is lie along x-axis, as here x power 1. And number three, that in which direction it is lying. So it is lying in towards the negative side of x-axis. Why this is so? Because of opposite sign of square term and the term which is having power 1. So this parabola y square is equal to 4ax minus 4ax will be of this type. So this is how to find out the parabola in these two shapes. Similarly over here, if we put x as 0, y will also be 0. So therefore turning point is 0 in both the curves. Number two, we need to find out that along which axis these are lying. So as in both the cases we are having y power 1, therefore these parabolas are lying along y-axis. And third thing is that in which direction these are lying. So as here the signs are same on both the sides, so it will lie towards the positive direction. Let me draw this. Y square is equal to x square is equal to 4ay. So this is the curve which is x square is equal to 4ay. Similarly over here, this will be to the below side of y-axis, means negative side of y-axis, x square is equal to minus 4ay. So identifying these simple parabolas, we can easily draw the curve, and rest of the parabolas I'll discuss as it will be in the question. Next, let us look at the very basic concepts of circle. The equation of circle in the simplest form is given by x minus a whole square plus y minus b whole square is equal to r square, where a, b represent the center coordinate. AB represent center coordinate of circle and r is the radius of the circle. So by looking at the equation given to us, we'll find that if the equation of circle is given, then we can easily find out its center and radius by converting it into this form, or we can take the form of circle as x square plus y square plus 2gx plus 2fy plus c is equal to 0. From this equation, we can also find out easily coordinate of center. Coordinate of center are minus g and minus f, means half of the coefficient of x and y by taking negative of it. Then radius is equal to g square plus f square minus c and root of it. So even if the equation is given in this form, you can find out center and radius, and if it is given in this form, you can find out radius and center. And once the radius and center you know of the circle, you can easily draw the circle. Next, let us discuss about the simplest form of ellipse. The equation of ellipse is given by x square upon a square plus y square upon b square is equal to 1. And here is the figure of ellipse, where the major axis having the coordinates as minus a0 and a0. These are the extreme point of the ellipse on the major axis, and on the minor axis we are having 0b and 0 minus b for this ellipse when a is greater than b. So this is the case when a is greater than b, then x is the major axis and y is the minor axis, and these are the coordinates of extreme points on ellipse on major axis and minor axis. This is the ellipse having a is less than b. Equation remains same, which I have written previously: x square upon a square plus y square upon b square is equal to 1. Just we are having a is less than b. So in this case, y-axis is the major axis and x-axis is the minor axis. It will be better to go through a conic section of 11th class before going to the problems of this chapter. So I'll discuss problems of the same topic in my next video. Till then, stay tuned.